Dear colleagues, hello. I'm Vitor Barboza. I will present the paper titled Task Allocation with Simulated Annealing in Edge Computing to Industrial Internet. The applications that deploy Industrial Internet of Things, the IIoT, usually impose some specific requirements, such as additional computational resources for processing, the process of their tasks in real time, low network latency, and also the transmission of large volume of data. Cloud computing is often a choice for IoT applications in order to provide the processing results, but its latency can affect the real-time demands. And edge computing appears as an alternative for task allocation with the advantage of bringing the low latency. Here there is an example of IoT application scenario, which is used as reference for this proposed approach. The picture shows three layers of service. The layer one concerns to the factories, where multiple industrial devices works. The devices in this scenario are vehicles that carry out activities through the factory area. They are constantly moving, sensing, and acting with the environment and sending their computational tasks to be processed on the layer above. The layer 2 is the edge layer. There is one edge node dedicated to each factory, communicating by wireless and processing in real time the tasks receiving from those vehicles. And the layer 3 is the cloud computing that can be used to store and retain data in long term, but it's not used for processing purpose. So, taking that scenario as reference, the problem will cover the mobility in the IoT devices, uh, that there are multiple devices sending multiple tasks simultaneously, delay sensitive tasks and variable size, tasks that have deadlines to be respected. So the gap is to minimize the task's response time and the processing time in the edge node. The goal uh, is to attain the maximum of tasks deadline with the shortest response time by optimizing the task scheduling process on the scenario. Some researchers have been working in similar problems on the industrial field, and they are also proposing edge computing to process the device's tasks with different approaches. Some of them covers mobility, allocation with deadlines and limits, and registering the waiting time of the tasks in the edge queue. The total response time of task is calculated from the task transmission time from the vehicle to the edge node, plus the task execution time in the edge node, the waiting time in the edge node queue when it really happens, and each of these times has their specific formulas, which we suppressed on these slides. There is a constraint. Uh, the task response time has to be less or equal to the task deadline. So defining the objective function, it desires to minimize the response time from the group of all tasks M from all vehicles V that are sending tasks to the same edge node and attending their deadlines. The fitness function will work with the algorithms to determine the optimized result. It includes a penalty function that when an infraction is found, it will drive the scheduler to avoid them and select solutions that attend the constraint. This is the simulated annealing method heuristic working on the task allocation optimization. There are three procedures in this algorithm. The main one, from line 1 to line 21, is the simulated annealing itself. But it is supported by the procedure that generates the initial solution, where the tasks are being received and included in a list structure. And the other procedure is to calculate the total response time. This one will apply the fitness function and return the results to the SCA work on the optimization. The SCA will run all the interactions that it is supposed to follow, and after completing that, it will return the best solution found. Uh, the iFogSync simulator has been used to produce the tests and analysis. We generated some experimental scenarios varying the number of tasks being sent. The maximum was 45 simultaneous tasks, and also varying the different sizes and different limits and deadlines for the tasks types. Regarding the total response time, it was evaluated the average of 30 repetitions of the FIFO mode compared to the SA average on 30 repetitions as well. For each scenario, it is possible to see that the FIFO is getting higher response times in second uh, when evaluated, and the simulated annealing algorithm is getting low level of response times in all the scenarios. We also included here as benchmark the best result from those 30 repetitions found for the simulated annealing, and always with the best response in each scenario. We also evaluated the success attendance of the task scenarios. The FIFO is not attending even on the first scenario with a small quantity of tasks. It is getting around 80%, then decrease to 70, and around 50% of tasks in the S4. The simulated annealing is getting 100% in the first and second scenario, but across the number of tasks increasing, it is also uh, getting not fully attend of 100%, but much better than the FIFO, because it is getting around 80% and 75% in the S3 and S4 respectively. So we presented the approach of simulated annealing for task allocation in multiple vehicles on edge computing in order to minimize the response time and attend the deadlines. Some experiments with different scenarios were conducted to evaluate it, and the results show that the proposed approach obtained best results when compared to first in, first out mode in all scenarios evaluated. In the future works, we propose the use of a prioritization scheme so the SCA can define the order of services with greater precision. Those are the references that we cited. Thank you very much. Bye.